Okay. Hi guys. Good morning. Are you able to hear? Is everything clear? The video is
Yes, sir.
Okay.
Good morning, sir.
Good morning. Good morning. Yes. So yeah. So again, we come back to what to say, online classes, right? Fine. Last class we saw a very brief introduction about what are chemical reactions, what are chemical species, what are mixtures, what are pure substances, right? And we also saw how to write the chemical formula of a particular chemical compound, right? Okay, so let us continue on with it, right? So let us start with, say, if I ask you, what is the formula for aluminium chloride? Can you do it and tell me the formula, just like how we did last time, right? First, you have to know the atomic number, write the electronic configuration, then you go for finding the valency, then you swap. Okay, right, I'll say JlCl3, right? So guys, even though you know the formula already, right, you know already the formula is AlCl3, but try to work it out and see whether you're getting it by the method we have been following. Okay, so I gave you a small homework, right? I asked you to remember the atomic numbers of at least 40 elements or 30 elements, right? So hope you've done it. So aluminium's atomic number is what? Aluminium's atomic number?
13.
Yeah, 13. 13 is the atomic number of aluminium. Chlorine atomic number?
17.
Yeah, 17. Okay. So guys, you have to remember this, or else again I'm telling you, writing formulas again you have to go back to the previous method of marking up formulas, right? Okay. So anyways, so aluminium will have 13 as the atomic number, so it will have 2, 8, 3, and you see chlorine will have 17 as the atomic number, so it will have 2, 8, 7, right? Okay. So now for aluminium, to attain stability, in the sense that if I have to go for octet, right? So again, we mentioned last class, right? Anything and everything happens in chemistry, or any chemical reaction you see, or say any chemical transformation you're going to undertake, right? All of them happens because to attain stability, right? Okay, so I already told you that octet, which we are seeing in your lower classes, are one of the criteria, right? They are not the only criteria, right? There are going to be better criteria you're going to see when you come to higher classes. Okay, so anyways, so aluminium, now it has to form octet, so it has to lose 3 electrons. So it will lose 3 electrons to form aluminium. What?
You're right.
No. If aluminium loses 3 electrons, what will aluminium form?
Stability.
No. See, if sodium loses an electron, it will form Na1 plus. Same way, this in this case, what is ion? Yes, what ion? I told you the amount of positive charge will be equal to the amount of negative. Correct. Al3 plus. It's not cationality. It's not anionality. It's cation. Cations are positively charged. Anions are negatively charged. How are cations formed? Cations are formed by losing an electron, right? And same way for anions, I have to gain electrons. In this case, you see, aluminium is losing 3 electrons, right? So aluminium will form Al3 plus. I told you how to write the charges, ions, charge number, whether it's positive or negative. After 3 is the valency, and plus represents that aluminium has lost electrons. Okay, fine. I hope this is clear. How is it Al3 plus? Okay, fine. Now going to chlorine. Chlorine has 2, 8, 7, right? So it has to gain one electron to satisfy its octet. It will become 2 comma 8 comma 8 if it accepts one more electron, right? So chlorine will accept one electron to form
Cl minus.
Cl1 minus, but we don't have to write 1 as I already mentioned in the last class. You can just write minus. It is understood by default that it is 1. Okay, now that's it. So I have Al3 plus, I have Cl1 minus, put this here, right? So now 3 will go here, 1 will come here, so you will form AlCl3. Okay, right? Very easy. Again, same thing what I did in last class, just reminding you, revising you, how do you write the formulas, how do you go about the formulas of compounds. Okay, fine. Any other questions you have?
Sir, what does Octet rule mean, sir?
What does?
So you said that Octet rule, sir, that one.
Yeah.
Sir, like what does that mean, sir?
Oh, what do you mean by octet rule?
Yes, sir.
Okay. It's fine. See, now if you take any of these, say I take aluminum, right? So first of all, for what octet rule, octet or duplet, right? OCTET and DUPLET, duplet, octet or duplet. What does it mean? Is if you take an atom, right? Atoms are going to have some number of electrons, some kind of electronic configuration and all stuff, right? So what octet rule, or first we'll see what octet rule. What octet rule says is for the atom to attain stability, right? For the atom to attain stability, there should be 8 electrons in the valence shell. That means in the valence means last shell, right? Valence shell means last shell. So in the last shell, right, if the atom has to gain stability, it has to have 8 electrons in the valence shell, right? Now that's what we did here. You see, I have 2
Yes,
comma
sir.
8 comma 3, right? So now there are two possibilities. One possibility is I can add 5 electrons to this, so that become 2 comma 8 comma 8, or I can remove this 3 electron which I have mentioned here, so that I can become 2 comma 8. So either way, what you see that there are going to be 8 electrons in the valence shell, right? Now again, since you have two possibilities, I have already mentioned that anything happens in chemistry, we have to go for minimum energy expenditure. The energy expenditure is like very less amount of energy to be spent, right? So obviously for adding 5 electron, the energy spent is more than removing 3 electron. That is little easier. 5 and 3, obviously you can understand, right? So aluminium will choose to lose 3 electrons. That is it. Aluminium will lose 3 electrons to form Al3 plus. Same goes with chlorine. 2 comma 8 comma 7, adding 1 electron to form 2 comma 8 comma 8, again becoming stable. But in that process, chlorine will not be chlorine as such. It will become chloride ion, Cl minus. Okay. Now same thing goes for duplet. Duplet, the same thing. Instead of 8 electrons, I can even have 2 electrons, right? But that will work only for 3 elements, or let's say I would say 4 or 5 elements only. Or I would say if you know the periodic table, only the first period. But anyways, don't worry about it. It will work only for atomic numbers less than 6, right? For example, hydrogen, helium, lithium, beryllium, boron, all these compounds, all these sorry not compounds, all these elements. If you see, right now at that time you have to go for duplet, right? Maybe we'll take an example. Maybe it will make some sense. Now till now we saw only octet. We'll take an example for duplet compounds. Okay, fine. So your question is answered, Kanna. What is duplet? What is octet?
Yes, sir, I understood.
Okay, good, very good. Right, fine. Right. Say, let me take beryllium oxide. Okay, can you fetch the formula for me? I have beryllium oxide and I want to know what is the formula. Okay, first things first. What is beryllium's atomic number?
4, sir.
Yeah, 4. Yes, correct. Right now, you might get a question. You might get a question like this in your mind. Say beryllium, as you said, the atomic number is 4. So now I can write 2, 2. This is how we write the concentration. Right now, you can ask me, sir, already duplet is satisfied? Is it not? Right, the valence shell is actually containing 2 electrons. Right, so you can ask me this question, sir, how then is it even going to form a compound? Right, that's a nice question if you ask me. Right, but what you have to understand is, people, right, the duplet will work only for the first shell. Please remember this. Right, so if at all you can have duplet, right, the duplet can be there only in the first shell, in the sense that you see there are 2 electrons in the second shell. No, that is not duplet. But by the moment you go to the second shell, the only thing which has to get satisfied is octet, not duplet. Right, but if you're going to go for the first shell, then if it has 2 electrons, then I'm fine with it. Okay, for example, if I take hydrogen, right, now hydrogen is going to have atomic number of 1, so the electronic configuration is 1, 0. I'm just keeping 0. Right, now what will happen? Now this hydrogen has only 1 electron in the first shell. Now I can add 1 more electron to this, so it becomes 2, 0. This is possible. Right, this is okay for me, but not the other way around. You cannot add 6 electrons to this to make it 8. No, that you cannot do. So I mean, I'm saying that obviously you can do that, but again, that not happen. But you see here, just because you have 2 electrons in the valence shell, please do not assume that duplet is satisfied. Again, I repeat, duplet is only for the first shell. If you're going to go for the second shell, you have to satisfy only octet. Okay, right, fine. So in this case, what is going to happen then? Right, in this case, again, you have 2 possibilities. Right, now the 2 possibilities are going to be a little different here. What is, I mean, same one adding electron, the other one is removing electron. Yeah, helium is duplet. Correct. Yes, Harita. Right, fine. So you see, this 2 electron can be lost, or I can add 6 electrons. 2 possibilities. Right, so if I remove this 2 electrons, what will happen? The configuration will become 2, 0. Is it not? Right, now if I add 6 electrons to this, it will become 2, 8. Right, again 2 possibilities. Minimum energy consideration. Obviously, if I consider minimum energy, losing 2 electrons is only easier. Right, now why am I losing 2 electrons? Because if I lose 2 electrons, duplet is satisfied. Please understand here. If I lose 2 electrons, duplet is satisfied. If I add 6 electrons, octet is satisfied. Again, we all go for minimum energy expenditure. So what will happen? Beryllium will lose 2 electrons to form
B2 plus.
absolutely, Be2 plus. Now we understand why is it forming losing 2 electrons. So we understand that it is because of satisfying duplet. Okay, fine, good. So now we say oxide. Oxide, we already know atomic number is oxygen atomic number
8. 8.
8. Yes, so it will become 2, 6. Now obviously, again you have 2 possibilities: removing 6 electrons to form duplet, or adding 2 electrons to form octet. But again, we choose the lesser energy one. So oxygen will accept 2 electrons to form O2 minus. Now that's it. We got the formula: beryllium 2 plus, oxygen 2 minus. Put this 2 here, put this 2 here. So what we'll be getting is Bu2O2. But this is not the correct one. Yes, answer is PEO. Correct, Harita. Right. So now what we do, we write the simplest formula. Right. So we'll cancel these 2's. So we'll write BeO. That is the formula for beryllium oxide. Okay. Right. So we saw one example for duplet also. Right. Now, based on this octet and duplet rule, right, we will be able to explain whether a particular element can form a compound or not. Right? There was one question, helium. Right now, okay, first to take this down, we'll speak about it. If you have already taken this down, well and good. If not, please take this down.
Completed, sir.
Okay, good. Right. So what I'm trying to tell you is, based on by looking at the electronic configuration, right, you will be able to predict whether that particular element is capable of forming a compound or not. For example, if you take helium, right? Now helium, I know the atomic number is 2, so I can directly write the electronic configuration to be 2,0. We can just write just 2, right? Now what you see here is helium has only 2 electrons, and those 2 electrons are in the first shell. That means what? Already duplet is satisfied. Already duplet is satisfied. So what do you expect? Obviously nothing will happen. It is not going to lose 2 electrons. It is not, nothing is going to happen because it's already stable. What is the criteria for stability? Criteria for stability is either octet or duplet. Now in this case, in case of helium, you see that it is already duplet satisfied. So what is going to happen? Helium is not capable of forming any compounds. Right? So this is the case with all elements known as noble gases. Have you ever heard this term, noble gases? Have you ever heard this term? Anybody? Okay, so I suppose even if you have not heard of it, it's fine, not a big deal at all. You will be studying them in this year in your periodic table chapter. But anyways, what I'm trying to tell you is, for example, helium is one such case. Helium belongs to the noble gas family, right? So if you look at the periodic table, if you look at, say, assume that this is the periodic table, right? So the last end, you are going to have some elements in. Okay, so you'll see the first element here would be helium, then it will be neon, argon, krypton, xenon. Like this, you will have elements. Anyways, don't worry about the name. You do not have to worry about it now, at least for now, right? So what I'm trying to tell you is all these elements are actually theoretically are not capable of forming any compounds. For example, if you take neon, we already saw hydrogen. It is not capable of forming any compound because already duplet is satisfied. Right. So if I take neon, for example, neon has an atomic number of 10. You can check, right? Neon has an atomic number of 10. So how will you write the configuration? We'll write it as 2, 8. Now see what you see. It's already, you see 8 electrons here. So what do you mean by that? Means that already octet is satisfied. It is neither can lose electron nor can accept electron. And obviously it cannot share electrons also. Why it has to share electron? Again, because of octet or duplet. Isn't it? Right? So you see all these elements, all the elements which are mentioned here, you don't have to worry about the names, not for now, right? But you have to know that noble gases are there. They have already octet or duplet filled configurations, right? So they will not be, theoretically again, they will not be able to form any compounds, right? But giving you a slight information, xenon, you see here, Xe, it's xenon, Xenon. Xenon is an element which is capable of actually forming compounds. Okay, so we have compound like XeO4, XeO2, XeOF4. So a lot of compounds like xenon can form compounds, right? Why? How? Sir, you said that octet, it is actually already satisfying octet. How is it able to form the compounds? And that is where you have to understand that octet is not the only criteria. I already mentioned it, right? Octet is not the only criteria for gaining stability. There are various other ways, right? Which you will be encountering when you go to 11th class. For now, all you have to understand is all of them are already octet or duplet satisfied. So theoretically, they should not be forming any compounds. Okay, right, good. So we understood all these things, right? So next thing, what we'll try to understand is Any questions till now? I hope everything is okay. Right. Fine. So next thing what we'll try to understand is there is something called as, now till now what you see, the cations or anions, you saw all of them are made up of only one element. The sense magnesium 2 plus, oxygen 2 minus, Cl minus. You see there is only one element there. For example, chloride means only Cl, only chlorine will be there. Magnesium means only magnesium will be there. That is pretty straightforward, right? But what we are going to see now is I am going to form a cation or an anion, but that is going to be made up of more than one element. Okay, right? More than one element, I'm saying. So how am I going to call it? Right? I am going to call them as polyatomic ions. Polyatomic ions. Okay, so from the name itself, we can understand poly means many. Atomic means many types of atoms are going to be there. Polyatomic ions. Till now, what we saw are monoatomic ions. What do you mean monoatomic? Only one element present, only one type of atom present. Right? So when I go for polyatomic ions, you will see that there is going to be more than one type of element present, or more than one element present, or more than one atom, one type of atom present. Okay, right. Fine. So first things first. Let me look at the cation. I think I have only one cation here, or I would say two. I can take two. Right. First one is what is called as my ammonium ion. Ammonium ion. Now, please don't confuse yourself. This is a very common confusion students have. Right. Ammonium and ammonia. You would have heard both these terms, right? Can someone tell me what is ammonia? What is ammonia? It's okay if you're wrong, doesn't matter. Well, can somebody guess what is ammonia? Yeah, NH3. Yes, right. So ammonia is basically a compound, right? So ammonia is a compound. The formula is NH3. Okay, nitrogen and one hydrogen combined together to form NH3. But anyways, don't worry about it. Right, ammonia you might have been learning from the lower classes. NH3 is the formula. Right. Now, please understand, people. Right. Whenever you see there is a species which is ending with IUM, aluminium, magnesium, calcium, ammonium. Right. So whenever you see this kind of stuff, you easily understand that they are going to form cations. Please remember this. Okay, right? So whenever you see IUM ending in the chemical species, sodium, aluminium, say here ammonium, aluminium, like that, wherever you see IUM present, right? Those times you have to understand lithium, yes, any metal you take, cesium, magnesium, calcium, beryllium, anything you take, any metal you take. We'll again come back to metals and non-metals next chapter. So wherever you see IUM ending, right, you can easily understand that they are going to form cations, or they're already cations. Doesn't matter, right? They're already cations, or they are capable of forming cations. That's what you can understand. Right. So by the moment you see IUM present, right, you can easily tell that this is not a compound. This is going to be an ion. Specifically, this is going to be a cation. Okay, right, fine. So now, what is the formula? I told you that it is going to be made up of more than one element, right? You see, ammonia is made up of two elements. One is nitrogen, the other one is hydrogen. Here also, you're going to have the same. Nitrogen and hydrogen are going to be present. Look at the formula. Formula is NH4 1 plus. NH4, yeah, NH4. You should not say just NH4. You have to say NH4 1 plus Harita. Right? Okay, NH4 1 plus. If you do not mention this, it's wrong, absolutely wrong. Okay, because we already mentioned, by the moment you see IUM, right, you must understand that it is a cation. Okay, right, fine. Now there is one more which we don't see generally common, but you will see that coming in next chapter, acid bases and salts. That is hydronium ion. Anyway, you don't even have to write it because it's already we can understand from this IUM that it is again going to be a cation. Yes, right? Okay. Now, what is the formula? Formula is H3O plus 1 plus. Right? You must have read about H plus. H plus is for acids, right? So the better way of writing H plus is actually this H3O plus. We'll speak more about this. We'll speak in depth about this H3O plus ion when you go for the next chapter. But for now, just know the formula, right? Now you can ask me, sir, do we have to mark it up? Do we have to remember the formulas? I would say, sadly, yes. But there are ways by which you'll be able to remember, right? Now, for example, how will be able to remember is, okay, say I have NH4 plus. Okay, fine. Now let us try to understand how are we able to get this particular formula, NH4 plus. Why only NH4 plus? Why not NH3 plus, or why not something else? Right? Those are the questions which should knock the doors for you. Right? Now we'll try to understand. Okay, fine. Now nitrogen. What is the atomic number of nitrogen? Atomic number of nitrogen? 7. Right? Atomic number of nitrogen is 7. Right? So how will you write the configuration? It will be 2, 5. Right? Okay. Fine. So if it's 2, 5, now what should happen? For me to satisfy octet, it has to accept 3 more electrons. So nitrogen will accept 3 electrons to form N3 minus. You understand? Because the 3 electrons are accepted, so it is going to form 3 minus. Okay, right. Fine. So now if I go for hydrogen, hydrogen is actually a very weird species, right? Hydrogen is going to have 1 as atomic number, and that is electronic configuration. That's okay, right? So now hydrogen can do both the things, in a sense that it can lose 1 electron to form 0 electron, no electron in the in the shells, or it can accept 1 electron to form H minus. We'll see about it. Okay, right? It can accept 1 more electron to form H minus. So, but in this case, you see nitrogen has already accepted electron. Right? We already spoke about this, sir. How do we understand which to accept electron, which to lose electron? If you can get one of them out, that in this case we found out that the easiest way to form octet for nitrogen is by accepting 3 electrons. Obviously, the other one, whatever is there along with it, should lose electron. Right? So hydrogen will lose an electron to form H plus. Okay, right. Now we understand that all the compounds are neutral. All the compounds are neutral, and that is the reason why we are able to subscribe. For example, if I have to get the formula for ammonia, I will be able to get from here. How? Say I have N forming 3 minus, N3 minus, and I have hydrogen to form H plus. What will I do? I will put it here, I will put it here, and I'll be getting NH3. That is not an issue. Okay, right. Now, you see ammonium, it is having an extra positive charge. It is not neutral. Is it not? Right? It is having 1 positive charge. Right? So what you can understand is NH3 is neutral, right? So I have to add somehow some amount of positive charge so that it becomes NH4 plus. So 2 differences you can see. First difference is ammonia is neutral, ammonium ion is positive. Second difference is what? What is the second difference you can see? One difference is it is neutral and this is positive. what is the other difference you can see between ammonia and NH4 plus? Look at the formula and tell me, what is the other difference you see? No difference.
In ammonia, there are 3 ions for hydrogen. And
Yeah.
for ammonium, there are 4 ions for hydrogen.
Exactly, right. So you see that there are 3 hydrogen atoms here, NH3, and here you see there are 4 hydrogen atoms. Right. That means two differences. One, this is positive, this is neutral. Second, it has 3 hydrogens, it has 4 hydrogens. Okay. Now we'll try to connect these 2 differences. Okay. Now what happens? Now you
Sir,
see.
I don't understand how it is neutral, sir.
How is it neutral? Do you see any charge here, Kana? Overall in ammonia, do you see any charge overall? Obviously, nitrogen has some charge and hydrogen has some charge, accepted, right? But you see, nitrogen is having 3 minus, okay, and hydrogen is 1 plus. But how many hydrogens we have? We have 3 hydrogens, both, each of them having 1 plus 1 plus 1 plus, right? So I have 3 minus, 3 plus, overall charge is 0. Yes, understood?
Yes, sir.
Right, like this. Not only for this, any compound you take, the overall charge of the compound is 0. Any compound for that matter.
Yes, sir.
Okay, right, fine. So we understood that this is neutral and this is having positive charge. We can see here there is a positive mention here. Another difference is 3 hydrogens and 4 hydrogens. Okay, so how we will try to connect these two. Right, now you see hydrogen is actually forming what? Hydrogen is forming H plus, right? So what I can understand is I have to add 1 positive charge and I have to add 1 hydrogen to ammonia so that it is going to form NH4 plus. Very easy, right? Can I write it like this? NH3 will accept 1 H plus, right? NH3 will accept 1 H plus to form what? To form NH4 plus. Isn't it? Ammonia is neutral. I need, for forming ammonium ion, I should have a positive charge. Yes, okay. And also I should have 1 more hydrogen atom. 4 hydrogen should be there. And both the things are going to come positive charge in the form of hydrogen. If I can do it, my problem is done. You see, NH3 will accept H plus, right, to form ammonium ion. H plus, we know how is it being formed. Okay, right. Now you can easily understand how the charge is 1 plus also, right? I know for nitrogen the charge is -3. We saw here. Where is it? N3 minus. Yeah, you see here, right? Nitrogen is having -3 and hydrogen is having +1. Right? How many such hydrogens? 4 such hydrogens. I can write it here. -3 for nitrogen plus 1 for hydrogen. And how many such hydrogen atoms? 4 such hydrogen atoms are there. Obviously, what is the residual charge? Residual charge would be +1, and that is what you put here. Okay, right? Fine. Like this and all, I don't think you will have time to do in your examinations. But again, first time, whenever you're gonna write a compound, whenever you're going to write the formula, it's better that you understand all this and you write all this and try to remember the formula. Okay, right? So ammonium ion, the formula is NH4 plus, and I'm reminding you, we are speaking about polyatomic ions. Right, that means the ion is either cation or anion, is made up of more than 1 type of an atom or an element. Okay, fine. So we understood how NH4 plus is getting formed. Ammonia will accept H plus to form NH4 plus. Right? Okay. Same I can understand with your H3O plus. Right? H3O plus, I can give you a similar kind of explanation, but you have to cut it short, right? You can easily understand. Again, hydrogen will form +1, obviously, right? And then it has 3 such hydrogens, Right, okay. Now oxygen is having how much? -2. You can remember O2 minus is what is going to form, right? So -2, right? So +3 -2, again you will see you'll get the residual charge as +1, right? So if you can remember how many atoms of each element is there, if you can remember that there are going to be 3 hydrogen atoms and 1 oxygen atom, you can actually get what is the overall charge that you'll be able to get by this method, what I mentioned here, right? You write the overall formula, right? You see that there are 3 hydrogen atoms, each of them is capable of forming 1 plus, and there is only 1 oxygen atom having -2. So you just add up all the charges possible. What will you see is the residual charge to be equal to +1, and that is the charge you write on the top. Same goes for here. Okay, right? So, but anyways, at the end of the day, you have to remember all the formulas along with the charge. That is what is more important. Okay, right. This hydronium is not important, but at least the ammonium ion is very, very important. Okay, fine. So any questions? Any questions till now? Even if it's a stupid question, please don't mind. Please ask. Any questions? Okay, I suppose everything is clear. Right. So now we saw only cation. Right. So we'll try to, what is the time? Okay, fine. Right. So we saw only cation. We'll try to see some anions as well. Right. So polyatomic anions is what we're going to see. Right. Now, sir, how do I identify by the name of the ion? How do I identify whether it's a cation or anion? I already told you how to identify a cation. If you see that the name is ending with IUM, right? The name is ending with IUM, then it's a cation. Now, how will I do for anion? If you find that it is ending with E, chloride, oxide, sulphide, nitride, nitrate, sulphate, all these things, whatever you see, whenever you see it is ending with E, that means it is definitely going to be a anion. That's what you need to understand. Okay, now there are going to be so many anions you're going to see, on all of them you have to remember. Okay, right? But again, I'll give you some tricks to remember, don't worry. But again, at the end of the day, all things has to be remembered for you to write the formulas. That's what I'm telling. Okay, fine. So we'll start with something very simple. Okay, so you have first one to be hydroxide. Okay, hydroxide anion. Okay, fine. So the formula is OH1 minus. This is the formula. We already, I think, know this. Okay, hydroxide is OH minus. Okay, right, fine. Next, we'll next we'll go for sulphide compounds. See, and one more thing. Okay, so you have, generally when you go for anions, right, you will see that it can end up in 3 ways. Obviously, ending with E, right? But before E, what all you can have, I'll tell you, right? You can have IPE, or you can have ITE, or you can have ATE. I think you can get, you can correlate. For example, you write oxide, IDE. You can write sulphite, ITE, or you can even write sulphate, ATE. All these are anions, right? How do I identify, sir? Right. Now, one thing I can tell you for sure is by the moment you see IDE, right, you understand that only that element is present. Right? Only that element is present. For example, what do you mean by only that element is present? You see, oxide means only oxygen and nothing else. We know the formula, oxide is O2 minus, right? Chloride Again, you see IDE. That means only chlorine is there. So you know you're going to form Cl minus. Okay. By the moment you nitride, again Nitride, again you'll have N3 minus. Okay. So what you have to understand is by the moment you see IDE ending, that means only that element is present. In the sense, it is going to be a monoatomic anion. Okay, monoatomic anion. Only that element is present. You can understand from the examples here. Okay, fine. Now, what about these two, sir? What about ITE and ATE? Okay. Now, please understand, people. ITE and ATE. By the moment you see ITE and ATE, what you have to understand is there is going to be one element, right? And that element is going to be present along with oxygen. Okay, that element is going to be present along with oxygen. For example, if I write sulphite, ITE, it's ending, right? So what do you see from the first part, sulph? You can understand that sulfur is there, right? Right, and you have to look at the second part. Second part is ITE. If it was IDE, then what would have happened? Only sulfur would have been there, right? But you see sulph, ITE is there. That means it has to come along with oxygen. It has to come along with oxygen, right? Same goes with for sulphate. Sulph, only if at all sulphide is there, only sulfur. Now you see sulph, okay, sulfur is there, I understand. And you again see ATE. Again, that means oxygen is going to be there along with sulfur. Okay, both the things I'm telling that sulfur and oxygen, that means definitely the formula is going to be different. The charges can be different. Okay, right? So fine. So first things first, IDE means only that element, right? ITE or ATE, both of them, if you see, you have to understand that that element is there along with oxygen. Along with oxygen. That's what is more important. Right. One more thing also, I'll tell you. Right. What is the other thing I want to tell you is the number of oxygen atoms in ATE. That means sulphate and sulphite. Both of them have oxygen. Isn't it? Both of them has oxygen, right? So what you can understand is the number of oxygen atoms in 8 compounds are greater than number of oxygen atoms in 8 compounds. Okay, number of oxygen actually it will be one more than 8. Remember this. Okay, right? Again, repeat what I'm trying to tell you. Right? If I take 8 compounds, ITE, T for tap, right? ITE compounds. What I'm telling is the number of oxygen atom in ITE compounds is lesser than the number of oxygen atom in 8 compounds. If I give you one example, you'll easily understand. Right? For example, okay, you just take down these points. I'll just give you the examples. First thing, IDE means only element, only that element. ITE, ATE means that element along with oxygen. Okay, and always remember that ATE will have more oxygen atoms than the ITE compounds. 3 points alone you note. We'll see some examples now. Okay, right, fine. So let me give you some examples for this. Can I this
Sir,
part?
can you repeat the 3 points, sir, which you told to note down?
Yeah, sure. So it's all about these 3: IDE, ITE, and ATE. All these are anions. I told you, by the moment you end with E, it is an anion. Okay, fine. There can be 3 types of this ending with E: IDE, ITE, and ATE. IDE means only that element is present. For example, say oxide, IDE, only oxygen. Sulphide, IDE, that means only sulfur. Fluoride, chloride, all these things you see, there only be only that element present. That is the first point. Second point is IDE, sorry, ITE and ATE, when you see that coming, that means there will be that element and that element will be along with oxygen. For example, you see sulphite or sulphate means in both these compounds, sulfur plus oxygen will be there. Both of them will be there. By the moment you see ITE or ATE, you will find that it is going to be along with oxygen. Nitrite, nitrate, again nitrogen plus oxygen, both these cases. Right? Okay, that is the second point. Third point is the number of oxygen atoms, right? The number of oxygen atoms in ATE is greater than the number of oxygen atoms in ITE. Right? When I give you an example, this point will be clear. Don't worry. These are the 3 points. Okay? Any understood?
Yes, sir.
Right. Okay, good. Right. So now we'll try to understand the example. How is it that ITE compounds having lesser number of oxygen atoms than the number of oxygen atoms in ATE? Right. Okay. Now the next polyatomic anion we can see is sulphite, ITE. Okay. Now you see the formula is SO3 2 minus. Okay, you can see that. I told you whenever you see ITE, it has to come along with oxygen, right? You have sulfur along with oxygen, the charge is 2 minus. Okay, fine. Now next one is sulphate. Okay, now again, this is also going to come along with oxygen, but the number of oxygen atom will be 1 higher. For example, you see here I have 3 oxygen atoms. The next one is going to have 4 oxygen atoms. Very simple. SO4, you see the number of oxygen atoms is 4. The charge is same. SO4 2 minus. Right? So SO3 2 minus is sulphite, ITE. SO4 2 minus is sulphate. I told you the number of oxygen atoms in A will be higher than in the case with ITE. Same thing, I can go for say nitrite. Nitrite would be NO2 1 minus. Now if I write nitrate, it would be NO3 minus. Now again you see the 8 compound is having 1 oxygen atom higher than the previous ITE compound. Nitrite, nitrate. Again, if I say nitride, IDE, then what is the formula? If I write nitride, what is the ion? Can you tell me what is the formula of the ion?
N1.
N.
N1.
No. See, first of all, the charge itself is wrong. By the moment you see E, it should be a positive charge or negative charge.
Negative, sir.
Negative charge. Okay, fine. Next thing is by the moment I see ID, what I understand?
Only nitrogen, sir.
Absolutely. Only nitrogen is present. Okay, so only nitrogen is present. And the moment I see E, it means it is going to form an anion, that is a negative charge. Can you tell me what kind of negative charge nitrogen will form? Go for the electronic configuration and tell me the answer. Nitride. Just now we saw in the case of ammonia, what nitrogen is going to form. You again do it, not an issue. Yes, what is the charge for nitrogen? Nitride, what is the ion?
N3 minus.
Absolutely correct, right? So you again see, if at all I have to mention you, nitrogen is having 2, 5, 7 is the atomic number. So you see I have to add 3 more electrons to satisfy its octet. So nitrogen will accept 3 electrons to form N3 minus, and this is what is the formula for nitride, IDE means only nitrogen. And the formula of the ion is N power 3 minus. Okay, fine. This is just to go back and explain you. And 3 minus is okay. Okay, so we saw sulphite, sulphate, nitrite, nitrite, and then we can even go for carbonate. Okay, carbonate. Now you see again ATE coming. There is no carbonite. There is no ITE here. For carbon, there is only one. That is carbonate. Okay. Now the formula is CO3 2 minus. Carbonate. Again, you see carbon, only carbon 8. 8 represents oxygen. So carbonate, carbon plus oxygen. CO3 2 minus. Okay. Right. Fine. Anything else? So many are there actually. Okay. Now you will have bicarbonate. Okay. What is this? Right. Even you have bisulfite. There are stuffs like this. Okay. Now what do you mean by this is by the moment you see bi, right? That means you know the other compound carbonate, you know, right? So what you do is for this bi, you add the H plus along with the carbonate. Okay. How do you get a bi? I'll write bicarbonate is equal to H plus the carbonate. Right? Bicarbonate is equal to H or any bi compound for that matter. Right? Bisulfide means sulphide plus H plus. Right? So I can write bi is equal to H plus the 8 compound generally, or 8 compound, whatever it is. Okay, so you just have to add the H plus to the compound which you're talking about. So see, you have here you have carbonate. Carbonate is CO3 2 minus. Right? Carbonate is CO3 2 minus. Now what I told you, for bicarbonate, you add a H plus to this. Can you tell me what you can get if I add if I have CO3 2 minus and if I add H plus to this, what will I get? Can you just guess?
HCO3 2 minus.
HCO3 is correct. Okay. Now you see, you have the overall charge. Overall here the CO3 is having 2 minus and hydrogen is having 1 plus. So what should be the charge here? -2 plus 1. What will be the charge?
-1.
Exactly. So HCO3 minus will be the correct. Sarita, correct. It should be HCO3 minus. Now I told you bi means add H plus to the whatever the compound we have. Right? So I told you carbonate is CO3 2 minus. You add H plus to this. It is not only about the elements getting added, it is also about charge getting added. Right? Here you have -2, here you have +1. So -2 plus 1 will become -1. So the overall charge of this ion, overall formula of the ion is HCO3 minus. Okay. Same way, can you guess what will be the formula for bisulfite, ITE? Can you just guess? You know what is the formula for sulphite, right? Bisulfite. Can you just tell me?
So HSO3 minus.
Yes, absolutely right. So you have sulphite to be SO3 2 minus. You see sulphite here, SO3 2 minus. You add a H plus to this. What will you form? You will form first HSO3. Now you calculate the charge. -2 plus 1, again -1. So you can easily write HSO3 minus. Yes, correct. Absolutely right. What is the time? Okay. So yes, these are all the you have still 2-3 more. We'll see next class. Now next class, what you have to do is first whatever we saw, try to remember them. Right. Next class we will try to write the formula with these ions. Obviously, barium sulfate, nitrogen, ammonium chloride, right? Sodium carbonate. Right. So all these can be different compounds, and this thing is very similar. How do you write the formula is very similar to what we saw. You just have to remember the formula along with the charge and your shift stop. For example, maybe I'll give you one example. Right. If I have to write, for example, if I have to write sodium carbonate, okay? Sodium carbonate. Okay, now sodium, again you have to write the electronic configuration, see what is the ion getting formed. Sodium will have 11, so it will have 2, 8, 1. So sodium will lose an electron to form Na plus. Sorry, I have to write it here this time. Right? 2, 8, 1, 1 electron is lost to form Na plus. So Na plus is there. Now carbonate, you see, this is the charge of, this is the carbonate's formula. Now again you do slip stack. Put 2 here, put 1 here. You're going to form Na2. 2 will come here. CO3 has only 1. Okay, Na2CO3 is the formula for sodium carbonate. Okay, so like this we'll see many more examples, but all you have to remember is the formulas of the ions, and then you can slip swap to get the overall formula of the compound. Any questions, guys? Any questions? Okay, so I suppose everything is clear. So I think that's it for today, people. Okay, so next week we'll continue. We'll try to get the formulas out. See, this and all has to be, you should have done in your 9th or 8th classes, but I don't know how much you would have done it, but that's why we are spending some time here, because I can directly go for the chapter and write the chemical equations, chemical formulas. I can directly write, but what will you do is you'll end up mugging up all these things. I really don't want that. I really want to change the stereotype that in chemistry you have to mug up formulas. No, you don't have to. Right? Get that to your head. Right? I think that's it for today. If you don't have any other questions, we can wind up. Is it okay? Can we wind up, people?
Yes, sir.
Okay.
Sir, in
cool.
that NaCO3, sir,
Na2CO3.
2 minus and plus is there. So can't it be like NaCO3? Sorry, yes, sir, NaCO3.
See, you see, I write it properly. Na plus 1 plus CO3 2 minus. Now please understand, you have to swap only the charge and nothing else. Now what happens? 2 will come here to sodium, right? And 1 will go to carbonate. That means nothing will happen, right? So what do you see? Sodium is getting 2 and carbonate is getting nothing, 1. So that's why the formula is Na2CO3. Yes? Okay, cool. Fine, guys. Thank you so much. We'll meet again next week.
Thank you, sir.
Yeah,
Thank you, sir.
Thank you.
Thank you, sir.
Yes, thank you.